And that is the beginnings of the bottom half of our mold. All right, so let me get all the ejector pins and we'll start cutting and grinding and placing ejector pins. All right, so I am going to use this, what is this, a 8-inch caliper. I'm going to stick the tip down inside of the pocket for the ejector pin base to sit in. And then I'm going to measure to the top of the parting line of this mold base. And we got 141.4 millimeters. So this is the ejector, one of the ejector pins. This is a 16th or 1.6 millimeter ejector pin. And hopefully these are not too small, but again, we're going to find out. If they are too small, we'll have to add more. But I'm using a small diameter ejector pin to basically push on the ends of the ribs of the plastic part. That's the best place to push, because the rib of a part distributes the ejection force across its structural frame, if you will, as opposed to pushing on just a big flat area of plastic in the middle of the cavity. That way, you know, the ejector pin can bow up or even punch through the plastic because it's a weaker area of plastic. But pushing on the ends of like a structural frame or a rib structure is much better. So that's why we're using these small 16th inch ejector pins. So there's a few ejector pins that are basically flush with this surface of the mold. You know, the four corners, and then a couple where the sprue is for, you know, where we eject out the sprue. So I think what I'm going to do is start with the corners that are closest to the parting line of the mold, which I just measured. And then what we can do is for the other ejector pins, which are taller, like the ones that are in the vertical stack of the cavity, we can basically use the CAD to measure a good pin and then add the distance for what the CAD model says, so that we don't have to spend all day grinding and measuring and grinding and measuring. We're going to rely on the CAD a little bit. So let's do that. So 141.4, and then there's about 50 microns additional for the shut-off surface or the seal surface around the mold cavity. So we will account for that as well. So 141.45 is going to be the height of at least the beginning ejector pins that are flush or close to flush with the parting line. So I'm going to start cutting these and grinding them. It's kind of boring work, so I'm not going to subject you to all of that. And we'll be back when I've got at least most of the ejector pins cut. Okay, so I'm going to enter from the downspin side of the wheel. So we'll turn on I'm going to double check the mag chuck. It's always a good practice. So we're completely on. The stone is above the part to grind. Oh, that's coolant. So we'll turn on our stone here. And if you come in from this side of the stone, if the part jams up and kicks out, it's already leaving the stone. So it's a lot safer to come in from the downspin side of your stone. So I'm going to start to find the first spark, which is there. And then I'll make sure no one else is taller. I'd rather not have too much flood with it being so high, because it'll kind of get everywhere. But I think I probably should start with a flood. So I got one hand on the X, moving back and forth, and one hand on the Z axis, dropping it down. I'm basically finding the same height for all of these. And then every now and then I'm going to change Y so that I don't run a rut into the stone. Okay, welcome back. So we've cut all of the ejector pins to length and ground them to length as well. And it's not very exciting, so I just did that off camera. So now what we're going to do is string all of our ejector pins into the appropriate holes, and I've kind of categorized them here. And then we can assemble the back of our plate on and keep moving forward with building out the B side of this mold. Oh, there is one flaky ejector pin right here, which kind of broke into this thread. and I will have to assess how to deal with that one. It could be that we just skip this bolt because I don't know if you can see it or not, but right here, one of the ejector pin holes is halfway into the thread for the bolt. So I think the easiest thing is to just not screw that bolt in. All right, so the ejector plate travels on 4 pins, which line up with these reamed holes. Yeah, so these 3/4 inch by 5/16 head pins are the guide pins that allow this ejector plate to move in and out, following these deep reamed holes in the aluminum block, or the B side of the block. So I'm going to open this and pull our pins out. And hopefully I don't have to grind the tips of these pins down. If so, it's going to be a hassle because then I got to load them up and grind them. But maybe they actually already terminate. Let me show you what I'm talking about. So these pins are also return pins. So if we zoom in, and check out how this works. So imagine this pin is captured in the ejector plate in the back. And then in the front here, this pin protrudes through the front or through the parting line of the mold. Now a lot of times these are like an 1/8 inch oversized, which is a real hassle. Hopefully this one's going to be flush out of the box, you know, so that when the ejector plate moves forward, this pin stands proud of the B side of the mold. And then when the cycle of molding is finished, if the ejector plate has a problem returning back to its home position, then this pin is going to be sticking out. So when the molding machine closes the A and the B side together, the A side will actually push this pin back to its home position and retract all the ejector pins ideally back to their home position. Now this can be problematic if there's certain cases where if like an ejector pin is jammed up and then the molding machine pushes this pin back, it'll actually just break or pull the ejector pin into 2 pieces. So then you still have a chunk of an ejector pin pushing or standing forward in your mold, and the molding machine, if it can't sense that it touches that ejector pin, then it can crash your mold. So these return pins are not always the ultimate safe solution to everything. It's a lot better to have your molding machine sense when it pulls back the pressure of the ejector plate pulling back, and you can set your machine up to say, hey, there's more pressure to pull this pin back than, or this plate, the ejector plate back than what I think, so the molding machine will stop. Other configurations are there's big springs that tie on to this ledge here, and the spring actually pushes the ejector plate back without the molding machine even knowing where it is. So I'm of the camp where I don't really like to rely completely on these return pins. And it's called a return pin because when the mold closes, it returns the ejector plate to the home position or to the back position. I'm not a big fan of them. I'd rather have the molding machine sensing and pulling and controlling this so that the machine has a better idea of the health of the mold that it's running. But anyway, so all that being said, let's go ahead and start stringing this stuff on. Well, you know, actually I can determine right now if it's the right height. Yeah, so let's lay this mold down. Yeah, it's the same process as setting the heights of the, oh, good. So it is, oh, you can't see it. Okay, so I laid this mold down and it feels like it's just slightly high. Like if I roll another return pin over it, I can feel it. So, yeah, it seems like I need to grind off maybe 10/1000ths off of these. Or it'll also just preload and kind of squish. Let's find out what the height difference is. I'd rather not have to start grinding this stuff. Yeah, 7/1000ths. Well, I may grind 7/1000ths off the top of these pins, so hold on. All right, so we're right next door on the surface grinder, and we're gonna take 7/1000ths off the tip of this pin. I guess it's better to be able to take off 7/1000ths than add 7/1000ths. So I'm gonna, it's a little tight quarters in here. I'm on the end of the mag chuck. So that's good. Let's find the top. Just going back and forth. Any day now. There we go. Okay. Yeah, let's start grinding. Hopefully this will be quick. So it's not going to be the best grind in the world, but it doesn't really need to be. So we'll do the rest, and then we'll head back over to the mold. Okay, so we ground our return pins here, and I don't really feel any transition on this one that's inserted, so that's nice. So now we're going to start stringing in all of our ejector pins. And to do that, we need to basically get our holding plate against the back of the mold. So let's flip the mold up. And maybe I'll spin it a little bit so we can all see. So this return pin comes out. So the top clamping plate of the ejector plate has these clamping pockets for the return pins. And they'll just go in like that. And these pins are nice to hold the plate on the back of the mold, so it's easy to string all the ejector pins into the correct holes. But we do have to get the orientation correct, which is this orientation. And then I will line up all the return pins into their guide holes. It's kind of tricky to get everything to go at once. And it's always nice to see the things line up. Just like that. So right now the ejector plate is completely forward on the mold, but it allows us to string all of our ejector pins in now. And every now and then I'm going to pull these back out to make sure that I've got the right length pin in the right spot. So it could be that we can just string them all in this style. So you can see how I've got the plate back, and these return pins are actually nice measurement tools to kind of simulate the pulled back position of the ejector plate. That way I can confirm if these pins are right. Okay, so this is a slightly taller ejector pin, so that one goes here. Yep, and I see it. That's good. All right, well, let's just get at it. Oh, this is a shorter one. Okay, so we finally got all of our ejector pins in, and they all feel pretty good. There's one that's a little tight, but I think it'll work itself out. And it's the one that had the funny drilling, you know, the half circle. So we may have to ream that one out if need be, but let's see how we progress. So now we can bolt on the back plate of our ejector plate. Making sure I get orientation correct. And I gotta find the screws. -1, because we've got one ejector pin that's overlapping a mounting screw. And hopefully everything lines up. Basically, we shouldn't see a gap. And we don't see a gap, so that's fine. So all of my little counter bores actually lined up with all the ejector pins. The counter bore is inside of this plate so that the two plates could actually be flush to each other. If one of the shoulders didn't have a counter bore, then we'd have an 1/8 inch gap here. So, which means that, you know, the rigidity of this plate would be less, and we've already compromised it a little by removing one of the screws. And we are getting close. I can feel it. And now we're basically locking in the perpendicularity of the guide pins, or the return pins for the ejector plate. So they, you know, they're the bearing surfaces for the ejector plate to slide, and also the pins that push the ejector plate back if the molding machine doesn't do it for some reason. So we'll get these nice and tight because these can loosen over time. Okay. So now we can lay this over to the side. It's starting to get heavy. And we are going to add our pillars to the bottom of our mold base. So I am going to chamfer the holes so that they sit nice and flush. Maybe this tool will do it. And then the pillars themselves are here. And I'm going to deburr that pilot hole, or that mounting threaded hole. This could use a little more. Okay. And find some 1/4-20 screws. This one's boogered. And we got to figure out the... Okay, I'll be right back. I got to get a couple of screws. Okay, so we got the 1/4-20 in there. It was a little tight on the head, so I think I can probably just spin this pedestal on directly, and that head will self-lock. There we go. Again, this pedestal helps support the middle of the molding block when it sees the pressure from the plastic shooting in. You know, it'll see 100 tons distributed between these two lines and then these pedestals, so it helps keep the mold and the mold cavity square in 2 dimension. I need like a pipe wrench, but I think that'll do it for now. This mold's going to come back off after we see how the first shots are, because inevitably there's going to be some update that needs to happen to something. All right. We are just about there. So now I'm going to carefully pick up the B side of the mold, check that there's no contaminants between the two, and lay it on there. And I don't believe, well, maybe I will align the, yeah. Just for good bookkeeping, I will align the origins. There's an origin stamped in this corner here, and then the other origin is here. So it's good to keep everything lined up with your mold. So if you got a shim or something, you know relative to the origin what you got to fix. Okay, so now we'll stick this thing on there. This may not have been in the best plan. Actually, let me do this vertical. Yeah, that's a lot easier. Okay, we'll slide it on this way, but you can't get crud in the bottom edge of your mold by sliding it on the table. There we go. Okay. Seems like it wants to go. There we go. I just had some stiction from the table surface. Okay, now with our long bolts, we'll bolt this mold back together. So close. We do have to make one final sprue ejector pin in the middle here. And hopefully that doesn't give us too much of a hassle. Try not to bust my camera. Have this thing fling off and hit the camera. Now the moment of truth is getting the A side of the mold and stringing it onto the B side and make sure that basically it all goes together. Hopefully that is the case, because the customers are coming. They're going to be here pretty soon to see this in action. So I'm cutting it close, of course. We want these to be pretty tight. Okay, there we go. So the sprue ejector is a 3/16 ejector pin, which just basically needs to be shorter than the surface of the mold. But I guess maybe the next thing we can do is see if the A and B sides go together well. So let me bring the A side up. This is where we don't want to ding our exposed mold surface. Okay. So it doesn't hurt to grease these as well. I think for now I'll just use some whey lube. That way I can ensure that kind of particles and things are also wiped off of these bearings. So these fits are a little tricky as well, because we've got basically an over-constrained system, or a very accurate zero tolerance fit. So these pins and bushings in the B side of the mold. So these bushings, they can angle lock as well, or jam up, just because of the, minuscule offset in X, Y, and Z creates a very small angle, but that creates a huge amount of stress at that point where the slight angle hits each other. So the trick is to get these going parallel and one smooth motion. Hopefully they'll just go together. So let's see what happens. All right, there we go. That's a real nice sound. So here's our mold, ready to go as soon as I stick a 3/16 ejector pin in this hole, which is going to be capped by the ejector rod, or contained by the ejector rod. So there we go. And the cherry on top is the lifting ring, so that we can pick this thing up off the table and put it on the floor or onto the cart to take it over to the molding machine. And then we got a second lifting ring, which is used to hold the two mold halves together, and I usually use a nylon strap, which I will find here in a second. And we'll do the final ejector pin too in the center. Good. All right. There we go. I got a truck over here. The hand truck. Got my chains all twisted. Oh well. There we go. Okay, and off we go to the molding machine. So we'll meet you over at the molding machine.